Hi everybody, I hope you enjoyed your day off for snow. So we're going to have to do a video lesson because as I told you, I'm in a meeting today. First thing we're going to do is talk about a warm-up. This question was one of the questions that was on your test toward the end. And it says you're standing 14 feet away from the edge of a cylindrical water tank, 26 feet from a point of tangency on the water tank as shown to the right or underneath. What is the radius of the tank? So if we look at this, the first thing we need to think about is, okay, where is the radius? So you can see the radius is from where it touches the line to here. And so I have a radius where that red line is, and then I have another radius from here, and all the radiuses are equal. There's two basic ways that you can do this. Oops, sorry. I wanted to move that out of the way, but I guess it's not going to let me. There are two basic ways that you can solve this problem. The first one is you can consider this a right triangle because every tangent line meets the radius at a right angle. So if we consider the radius x, you can call it r if you want, we can write an equation that says x squared plus the 26 squared equals, and this is the tricky part, equals 14 plus x squared. Much easier to do this with a pen. Oh well. Okay. So that would be if you're going to use this with if you're going to use Pythagorean and use a Pythagorean theorem and solve that. The other way you could do this is where we talked about, let me just duplicate the picture. There we go. Where you talk about going from a point to intersections on the circle. And some of you that did this had a little bit of a problem because if you're going to do it with how far is it from a point to the part of the circle, you have to make sure you go to where the line intersects with the circle. In other words, we have to do from this point P, this point where we're standing, to the first place it intersects the circle, times from where you're standing to the second time it intersects the circle. So that is 14 plus the diameter, because you're going all the way across the water tank, so that would be a diameter. And that is going to equal from where you're standing to the circle, to the first place it intersects, and from where you're standing to the second place it intersects. That is 26 times 26 because it's a tangent line, so it intersects in the same place twice. So if you solve this equation, you will get different answers depending which equation you do, but that's because you're solving for different things. In the second one, you're solving for the diameter. So if you want the radius at the end, you just divide by 2. Here, x is the radius, so when you solve this, you're already finding the radius. So the radius should be the same no matter which way you solved it. You just have to make sure what your variables are. The other thing to remember when you're doing this is that when you square 14 plus x squared, it becomes 14 times 14 plus 14 times x plus 14 times x plus x times x. You have to use you have to distribute that or FOIL that so you get that whole part. Okay, so if you work those out, you'll get the same. Okay, no matter which way that you solve this, you'll get an answer that says that the radius equals 17.1. Okay, here are the homework solutions from last night. So this was all the different nets with the dimensions on it. Note that this like 11.4 here, it doesn't matter whether you marked it here or whether you marked it here. You're going to get the same thing either way. Same thing with this one, whether this is 5.6 or you wrote it over here as 5.6, that either one of those is fine. This, you could not put it over here on the 5 because this is going to be a different height. Okay, you can always pause this to look at all those solutions, and there are the solutions for the rest of them. If you just found surface area by looking at like, okay, here's all the different sides I have, calculate the areas for each one, that is fine. You could have drawn the nets and shown all of it, or you could have just calculated the sides. Okay, so our goal today is to talk about volumes. Today we're going to talk about pretty simple volumes, and then tomorrow we're going to do essentially applications and volumes inside of volumes and kind of the more complicated ones. So on your formula sheet that you should still have that you're going to be able to use on your test, will actually be on the computer. You can't actually use the physical paper. This is the volume section. For general prisms, so that's general prisms could be a rectangular prism like here. It could be a triangular prism, could be hexagonal prism. It's the area of the base times the height. So this isn't like one side of the base. If I consider this bottom one here with the little right angles in it, the base, the area of the base is 12 times 5, which is 60, and then you multiply it by the height. So you could either do this one as the area of the base is 12 times 5 equals base area, which means 60 equals the base area, and the volume equals 60 times the height, which is 6, which is 360. If you considered the um, the more square, the one on the end piece, your base, it will still work. You would have the base area equals 5 times 6, which is 30, and then the volume would equal 30 times 12 because now the height is the 12. And so 30 times 12 also equals 360. And I should put units on here of centimeters squared, except it's really hard to write a square on here. So it is centimeters squared. Okay, another prism. And I know it's a prism because I have two congruent shapes that are the bases, the top and the bottom. So it's the top triangle and the bottom triangle. So I need to find, first of all, the area of that triangle. So the area of that triangle is not 8 times 6 because 8 times 6 are side lengths. Neither one of those is the height. Or not necessarily. You have to look a little closer. It's a little hard to see, but if you see this little right angle down here in the bottom, that's telling you that this is a right triangle. From this viewpoint, some of you might see it better than me, but it doesn't look like a right triangle to me with the 3D perspective. But this right angle is telling us it is. So therefore, 8 can be the base and 6 can be the height of that triangle that is the base. So if I'm looking for the base area for this would be 8 times 6, which is 48. And then the height of the prism is this 6 that's right here. It's not the 10, right? This is the triangle base. The height of the prism would be this height right here, which is the 6. So therefore the volume is 48 times 6, which is 288. And that would be kilometers cubed. I'm just going to spell it because it's easier than it is to do exponents. Okay, this one is a composite volume. If you notice, you have the prism at the bottom, and then you have a pyramid on the top. Now, there's a formula for the pyramid. Again, that capital B is the base area of the pyramid. So if we do the pyramid first, if we look at the base of the pyramid, that would be these pieces, this square that's right here. So this square is the same as the square on the bottom. So for the pyramid part of this, base area equals 10 times 10, which is 100. The height of the pyramid is something that we don't know yet. Okay, so the height of this pyramid, the height that we need is that inside height. Remember when I held up that clear pyramid and I put my finger in the middle in the air? That's the height that you need when you're finding the volume because you're not talking about the area of this surface where we can use that slant height. You're talking about the volume. So you have to have that vertical height down to the base. So what we can do is we can essentially put a little right triangle in here, and I drew one right down here where this red slant height is the hypotenuse of that triangle. The base of the triangle, the bottom half, would be over to the center of that prism. So in other words, it's going to be over 5 because it's half of the 10 feet and along the base, and it's going to be up. We don't know how many. That's what we're going to try to find. So we know that this bottom dimension is a 5 because it's half of the um, length of that base. And then we can use Pythagorean theorem to find the other piece. So if we use Pythagorean theorem, we find that the height of that pyramid, which is this vertical side on this little triangle here, is 10.9 feet. So we now know the base, we know the height, and all I did was do Pythagorean theorem on that and round it. So I get 10.9. So therefore the volume of the pyramid is 1/3 times the base area, which the base area we said was 100, times 10.9. And if we calculate that, we get 10.9 times 100 divided by 3 gives me 363.3 feet cubed. Okay, so that is the pyramid part of it. So now, I'll switch colors so it's easier to follow. Now we need the volume of the prism. So we already really did the volume of the prism. Very similar one before. So it's just the volume equals the base area times the height, which in this case the base area is 100 and the height is 32. So that gives us 3,200 feet cubed. Okay, so our total area is 3,200 plus 363.3. So 3,563, 3,563.3. I'm running off the page. Make that a little smaller, that'll help me. 3,563.3 feet cubed. Okay, that would be the total area of the whole of that whole prism. Okay, I'm going to end this one with here because I'm not going to quite finish in the 15 minutes that it allows me. And so then I will start a new one for the last, there's only 2 more problems that we want to talk about, and then you can work on your homework. So you'll have to click out of this one and open the second video file.